Okay, Assalamualaikum. So I'm Dr. Wanda Shahida, okay, one of the applied statistic lecturer. Okay, so in this video, I will discuss the subtopic 2.1 from chapter 2. Okay, so chapter 2 is about confidence interval. Okay, so a continuity from what we have discussed in chapter 1. Confidence interval is one of the inferential statistic lah. Okay, one of the inferential statistic method where here what we do is we estimate the value of the population, okay, we just estimate, we assume that the correct one or the true value or the true population value is in the value that we calculate, okay, the range of value that we calculate, or in the confidence interval that we calculate. Okay, so it is one of the inferential statistic method lah. Okay, we estimate the population value, okay, but we do not have the confirmed number. We just estimate that the true value that we need, it is in the range of the value that we calculate, the range, the confidence interval that we calculate. Okay, so when we start with the chapter 2 onward, so you should have access to the statistical table lah. So you should have your own statistical table, because we will use a lot statistical table for the chapter 2 onwards. Okay, so whenever we discuss chapter 2 here onward, you need to have your own statistical table, then you can refer lah. Okay, the expected outcome. So able to find the confidence interval for the population mean when population variance is known or unknown. Okay, so the population value that we try to estimate here, we have three type of the population value. We have the population mean here. Okay, we have the population proportion, and then we have the population variance and also population standard deviation. So standard deviation, it is square root of the variance. So we will discuss these three population values. So we try to estimate these three population value. Okay, so what we do, we calculate the confidence interval, and then we assume or we estimate that those population value is in that interval lah. Okay, that's why it is an inferential statistic. Okay, so for the content, we have about 7 subtopic here. So in this video, we are going to discuss the 2.1 here, and then I will continue with the next video 2.2. Okay, and the rest of it from the another lecturer lah. Okay, but actually you can find those video in our YouTube channel lah. Okay, next one. Okay, 2.1, we have estimate, estimation, or an estimator. Okay, so define and identify the statistical term of estimate, estimation, and estimator. Okay, what is the difference between those three terms? Okay, the probability function that represents statistical model such as Poisson, binomial, and normal distribution may include one or more parameters. Okay, so parameter here, it is our population value. Okay, so the parameters that have been widely used, we have mean, we have variance, and also we have the proportion. Okay, so in general, okay, we will go to the mean and variance when we have the quantitative data. Okay, and we use a lot proportion when we have the qualitative data. Okay, I hope that you see the difference. I hope that you know the difference between quantitative and qualitative. Quantitative numeric data, qualitative is a non-numeric data. So usually, it is not always lah. Usually when we have qualitative data, when we do the qualitative research, we will go to the proportion lah. Okay, so any functions of a random sample whose objective is to approximate a parameter is called an estimator. Okay, so we have the we have here theta cap. So theta cap here represent the statistic. What is statistic? Statistic is a sample value. Is the estimator for theta. So theta here represent parameter value or population value lah. Okay. So let's say that we try to estimate the mu. Okay, mu is a population mean. So estimator for the population mean, it is x bar, sample mean. Okay, we try to estimate sigma. So estimation for the sigma, it is as sample standard deviation. We try to estimate proportion. So proportion denoted by pi for the population proportion. So estimator pi is a p, small p here. So p is a sample proportion. Or we try to estimate sigma square, then estimator is a s square. Okay, so these are estimator for this parameter value. So in general, your statistic or sample value, they are estimated to the parameter value. Okay, so estimation is the entire process of using an estimator to estimate the parameter. Okay, so like what we are going to discuss, confidence interval here. Okay, confidence interval. So in this confidence interval, we will use estimator, for example, S bar or S. Okay, in order to estimate the mu or the sigma or the sigma square, for example. Okay, so the whole process of the confidence interval here, we call it as a estimation. Because in this confidence interval, we are using the estimator to estimate the parameter value. Okay, so confidence interval, the process of finding the confidence interval or to construct the confidence interval, it is an estimation process. Okay, because in the estimation process, we are using estimator to estimate the parameter value. Okay, I hope that you can see the difference between those three words. Okay, so we have two types of estimation. Okay, so the first one, we have point estimation, a process that produces a specific numerical value calculated from a sample data representing the unknown population parameter. Okay, so point estimation here. Okay, we have for example here, the point estimation, so we have specific numerical value. So what we do to estimate mu, we have the S bar. So S bar, the S square here, the P here, it is a point estimator. Okay, so a process that produce, so means that the process that we calculate the S bar, the process that we calculate the S square, and the process that we calculate the P. So this one, point estimation. Okay, so interval estimation, a process that produce range of values calculated from the sample data, forming an interval within which the parameter is estimated to lies. Okay, so this is what confidence interval lah. Okay, this is what confidence interval. We produce a range of value, okay, from the sample data given, okay, or from your sample data. Okay, and we assume that parameter that we need to estimate lies within those interval. Okay, so if we can sketch, so you have this. So we have lower limit, which is the A, and then we have the upper bound or upper limit of the confidence interval, which is the B. Okay, so we assume that parameter that we want to estimate, they lies within this interval. Okay, it could be, if you need to estimate the mu, then your mu somewhere in this interval. If we estimate the sigma square, then your sigma square somewhere in this interval, similar to the pi lah. Okay, so this is what we call confidence interval. Okay, so confidence interval, it is interval estimation. Okay, so properties of the good point estimator. There are 4 main properties of a good estimator. So this is just for your information. No need to do anything. We assume that the estimator that we use in this course is a good estimator lah. Okay, if we go further, okay, if we try to prove that it is a good estimator, we need to derive lah. Okay, we need to derive and prove that it is and check it is a good estimator or not. Okay, so good estimator, it is an unbiased estimator, consistency estimator, efficiency, and also sufficient. So these properties should be satisfied for choosing the best estimator of a parameter. In this course, we assume that the best estimator for a parameter has satisfied all the properties. So we assume that the estimator that we are used in this course, it is a good estimator lah. Okay, this is only for you to know what are the main properties of a good estimator. Okay, so we have through 2.1.3, the confidence interval. Okay, so it is an interval estimation. So a confidence interval give an estimate range of value which is likely to include an unknown population parameter with a specific probability within that interval. Okay. So the interval is usually written as a and B, or A or less than theta and theta less than B. The end point of the interval are the confidence limit, and the specific probability is called the confidence level. Okay. So commonly used, so the confidence level that commonly used is a 95%, okay, 90%, and also 99%. Okay, so confidence limit represent the lower and upper boundary, which define the range or the width of the confidence interval. By looking at the width of the confidence interval, we can get a good sense of the estimator precision. The smaller the interval width, the better the confidence interval describe the parameter, indicating that the interval estimate is more precise and accurate. Okay, so let's sketch a little bit. Okay, okay, I will sketch. Where to sketch? I will sketch here. Okay. Okay, so the confidence limit here. So the lower limit here denoted by the A. So A is a lower limit or lower bound of the confidence interval, and the confidence limit here, it is B, represent the upper limit or upper bound of the confidence interval. Okay, so the probability. Okay, so the probability of the parameter lies in this interval. It is 1 minus alpha. So alpha, we call it as a significant level or level of significance. Okay, so 1 minus alpha probability that the parameter lies within interval A and B. So because we have 1 minus alpha here, so this side it will be alpha over 2 and this side it will be alpha over 2. Okay, so if we have 1 minus alpha here multiply with the 100%, then you can get the confidence level. Okay, let's say that we have 5% of the alpha. So 1 minus 5%, 0.05, then you will get 95%. So 95%, it is a confidence level. Okay, so when we try to solve the equation, this confidence level will be given in your question. What confidence level that we need you to calculate? 95, 99%, or 90%. So from the confidence level, you should be able to get your alpha lah, because 1 minus alpha. Okay, let's say that without this. Okay, so 1 minus alpha in probability, let's say that you have 0.95. So alpha, it is 0.05. Okay, we need alpha in the calculation later lah. Okay. Okay, what else here? Okay, so the B minus A here, B minus A, it is a width of the CI or range of the CI. Okay, so similar lah. So it is a B minus A. Okay. The smaller the interval width, the better the confidence interval. Describe the parameter indicating that the interval estimate is more precise and accurate. Okay, that one we discuss after this. What else that you have here? Confidence level is a probability value. Okay, already discussed. Okay, associate with the confidence interval. Okay. So in general, so alpha value represent the level of significance. Okay, and sometimes we express as a percentage lah, 5%, 1%. Okay, the confidence level is also referred to the reliability of the interval if within the width of the interval as identifying its precision or accuracy. Okay. So based on the confidence level, we can discuss the width of the interval lah. Okay, and in terms of precision and also accuracy. Okay, and then this is how we interpretation of the confidence interval. Okay, I will discuss after this. Okay, I hope that you get this. Okay. Okay, I want to sketch something here. Okay. Okay, the point here, the smaller the interval width, the better the confidence interval. Describe the parameter indicating that interval estimate is more precise and accurate. Okay, interval estimate is more precise and accurate means that, okay, the value B, the width that we have, B minus A here, okay, they are close to each other. The value that we have here, they are close to each other. That's why it is more precise. Okay, more precise and accurate means that the data that we have within the width here, they are close to each other. So we have consistent data. That's why we say here, the smaller the interval width, the better the confidence interval. Describe the parameter. Okay, the smaller the interval width means that first width and second width here. Okay, so if one smaller than the second width here, means that one here is a better confidence interval. Describe the parameter that lies in that interval, because when we have smaller width, the data between that they will close to each other, means that it is consistent data, so that's why it is more precise and accurate. So when we have the smaller interval width, okay, so let's compare the confidence level. Let's say that we have 95%, okay, 95%, and we have 99%. Okay. Okay. So when 95%, okay, increase to the 99%, your width will be larger. Okay, your width will be larger. Okay, when 99% here decrease to the 95%, the width will be narrower, so smaller width. Okay, why it is happen? Why when we increase 95 to the 99%, the width will be larger? Because of error increase. Okay, because of the error increase. So when we do the estimation, you will produce the estimation error. Okay, so estimation error denoted by the E. Okay, estimation error. Okay, so why 99% reduce to 95%, the width will be smaller or narrower? Because your E decrease. Okay, because your E decrease. Okay, so if we sketch the figure here, so this is 99%, 0.99. Okay, so 0.99, so means that your alpha is 1%. Okay, your alpha is 1%. So 0.01. Okay, 0.99 means that so alpha 0.01, which is 1% lah. So divide by 2. So here is a 0.005. Okay, so 95%, you will have this. Let's see here. %. So 95% means that here, so 95% we have 5% of the alpha, divide by 2, so 0.025. So the probability here larger than this one, then that's why it will be shrink. Okay, that's why the interval here, okay, it is smaller than the interval here. Okay, so based on this figure, we can say that the width of the 95% smaller than the width of the 99%. Okay, so because of that, we can say that 95% better than 99% because of the width smaller. Why we have smaller width? Because of the error smaller, because of the error decrease. Okay, so what to do? what we need to do to decrease the error here. So we can control these three value. Okay, you can control the n when you collect the data. Okay, when we control the n, the variability should be controlled also lah. Okay, so we have sigma or s, and then this the alpha, and then the alpha. The value that we can control freely is a alpha lah. You can control your alpha, you can decide what alpha that you want, the value of the alpha significant level, whether 5%, 1%, 4%, 3% is up to you. Okay, in order to decrease the what we call the error here, the n must be larger. Okay, when n larger, the probability should be smaller. Okay, so back to the chapter 1, in order to have the consistent data or precise data, probability must be smaller. Okay, that's why here we need smaller probability. And the alpha must be increased lah. From, for example here, from 1% to the 5%. Okay. How to increase the E here? Then opposite to that lah. And smaller, sigma or alpha larger, and alpha decrease. Okay, I hope that you understand. So then in conclusion here, 95% better than 99%. Why? Because of we have smaller width. Why it is happen? Because of E smaller. Okay, because of the error smaller, because of the estimation error smaller. Okay, that's why 95% better than 99% because of E smaller. Okay, estimation error. Okay. Okay, so in general, okay, I do hope that you understand what is confidence interval. Okay, okay, how do we interpret the confidence interval? Okay, so you can interpret your interval your confidence interval in two ways. The first way, we can discuss that we can talk about the how confident we are that parameter that we estimate lies in that interval. So we can say that okay, we are 95% confident. Oh, sorry, it's already here. Okay, so 95% confident interval means that, okay, this is how we interpret. We are 95% confident that the true parameter, okay, the true parameter here, it could be the mu, if we talk about the mu, or it could be the sigma square or sigma or pi. Okay, depends on the question, depends what confidence interval that we calculate. Okay, so we are 95% confident that the true parameter lies within the interval. Okay, or we have to notify here. Okay, we have to notify what interval that we have. How to write? Okay, the interval here within A and B. So you have to notify what is A, what is B, and unique. State the unique if available. Okay. Okay, or you can interpret based on the probability. Okay, so 95% means that 95% confidence interval means that the probability that interval that the probability that interval, okay, so this is in general. Okay, okay, if not we have to state based on our answer. So the probability that A and B include theta is your parameter, okay, is 95% or 0.95. Okay, so this is how we interpret the confidence interval. Okay, You can always refer to the note lah. Okay, so in general, how do we calculate for the confidence interval? So in general, 1 minus alpha 100% confidence interval for the theta is given by this. Okay, so this is your A, the whole A, lower bound. This is your B, okay, the upper bound. Okay, so theta cap here, that's your estimator. So estimator depends on what parameter that we estimate here. If the mu, then estimator could be the S bar. Okay, and then we have the distribution for the theta cap multiply with the SD. SD is a standard deviation of the theta cap. Okay, so distribution here and how the standard deviation for the theta cap here also depends on what parameter that we need to estimate. Okay, so distribution here could be the Z distribution, could be the T, could be the F, or chi-square. So depends. So if if the parameter here is a mu, then most probably we are then the distribution that we are going to use, it will be either Z or T distribution. Okay, so SD also depends on the theta here. Okay, so the distribution for the theta cap multiply with the SD for the theta cap, that's your E, estimation error. So that's how we calculate for the estimation error. So similar to this upper bound and lower bound, the difference only on the sign here. Okay, lower bound, it is a theta cap minus the E, and upper bound theta cap plus the E. Okay, so similar lah. Okay, this similar to this one. Okay, so similar. Okay, so this multiplication of these two, it is a estimation error. So if we simplify, then you will have this lah. So theta cap minus E okay, so if this is your A, this is your B. If we calculate the width, B minus A in terms of the E, you will have that. Okay. Okay. Sikit. B minus A in terms of the estimation error, so you have theta cap plus E minus theta cap minus E. So theta minus theta, E minus E, then you will have 2E. That's why here you have this interval width equal to 2E. Sometimes in your question you are given only E. So how to calculate the width from the E? You just multiply with the 2. Okay, or sometimes you have width in that equation, so how to calculate the E? Then E is a interval width divided by 2. Or sometimes you just have the upper bound and lower bound value already, the upper bound and lower bound value. So how to find the E? How to find the interval width? So you have to know how to play around with the formula. Okay, so estimation error also called as a margin of error. Okay, another terms that you have to know. Okay, so what we have here, we calculate the A and B here. It is a normal confidence interval, means that it is a two-sided confidence interval. Okay, we also have the one-sided confidence interval. Okay, one-sided confidence interval, it is means that maybe at one time we just calculate for the A, or maybe we just calculate for the B. Okay, even though we calculate for the one-sided, still when we write the confidence interval, you have to write both sides. You have to write the lower bound or upper bound. Okay, for example, okay, let's say that we need the one-sided for the mu. okay, for the upper bound. So we just calculate for the B. Okay, so automatically lower bound here, no need to calculate. We just use the theory. So mu, it is from negative infinity for the until infinity for the certain mu lah. Okay, why I said certain mu, it is depends also on the variable. Okay, so certain variable it could be negative value, then it start from negative infinity. Certain variable it cannot be the negative value. For example, time, there is no negative 5 second, for example. So we start from 0. Okay, let's say that we have the common one in general, negative infinity to the infinity. So when we calculate the upper bound here, one-sided upper bound confidence interval means that we just calculate for the B, automatically the lower bound here negative infinity. That's how we write the confidence interval. You cannot write the B, just B. Okay, you cannot write only B. We have to write both upper bound and lower bound. Similar, if you calculate for the one-sided lower bound, means that we just calculate for the A. So automatically upper bound here, infinity. Okay, in general. Okay, so what is the formula for the one-sided upper bound and lower bound? Similar to this, sama. Okay, similar. Upper bound, we just use this side. And lower bound, we just use this side. Okay, and what we modify, the alpha. Okay, because you can see here, when it is a one-sided, automatically you will get this graph, 1 minus alpha for the upper bound, here only alpha. So we modify the alpha lah. If you have two-sided, and here alpha over 2, that's the only thing that we modify. Okay, when we go to the next subtopic, I will discuss in detail how we calculate the one-sided confidence interval. Okay, so here just a brief idea what is a one-sided confidence interval. Okay, that's all for this video. I will continue with the 2.2. Thank you.